So now we will try to check some of the theoretical requirements. The first one that we will look for is non-negative loading. Namely, does the principle in question satisfy that the premium we get upon calculation is greater than equal to the expected value of the total claim size? Now this is a very fair requirement because only an idiot will charge a lower premium than the expected value of the total claim size, because in that case you are sure to fail, right? So this is a very, very fair requirement to make, and let's just check this through very quickly. We're quite sure that in the case of the net value principle, the premium is the mean of the total claim size, and thus non-negative loading is definitely satisfied. And in the expected value principle case, since rho is greater than 0, well then we have that this thing is also greater than equal to the expected value of the total claim size, right? Since rho is greater than 0. And in the case of the variance principle, also since alpha is greater than 0, then we also have that non-negative loading is satisfied, and also in the standard deviation case. So this was pretty simple stuff. So all the four premium principles that we're looking at do indeed satisfy non-negative loading. Now let's try to look at the next requirement that we require. It may take a little bit more work. The next requirement is called consistency. And what does consistency require of the premium principle? Well, it says that if we consider a claim that has this size, so if we take the total claim size and add a constant, then this claim should have the price P of t plus c. So adding a constant to the total claim size should cost the same as just adding the price c to the premium of what was charged before. So this also kind of makes sense that if we know for sure that our total claim size will grow by $10,000 or something like that, well then the premium that we charge should also increase by $10,000. Or so we think anyways. Let's just try and see if these principles all satisfy this condition. So the net value principle, let's see what we have. Then we will have to consider the mean value of S of t plus c. And by linearity of mean value, we then get the mean value of S of t and then just plus c. And we recognize the first term just as the net premium plus c. So consistency is satisfied in the first case. Now let's try to look at the second case in the expected value principle when we try to price S of t plus c according to this. Well, then we kind of get a problem, right? Because I see that I can take the mean of S of t first, but then I have to add 1 multiplied by c plus rho multiplied by c. And that's a problem because this is not equal to the premium given by the expected value principle of S of t. So because this part is this. I mean, this is not equal to this because I have an extra rho c term. And because of the extra rho c term, this principle does not satisfy consistency. Now let's try to look at the variance principle. And already quite quickly we can establish that we are really quite safe because in the variance principle we plug in S of t plus c here and we plug it into the variance expression, right? And we all know that variance is translation invariant. That means that if I take the variance of some variable x plus a constant, then the variance just stays the same as it would have been for x. So because of this, I have that this expression is just the mean of s of t, and then plus the c that goes outside the expectation, and then plus alpha multiplied by the variance of s of t, which I can then recognize. I can recognize the first term as just the variance principal premium of s of t, and then I have plus c. So the variance principle also satisfies consistency. And in exactly the same way, we can conclude that the standard deviation principle also satisfies consistency. It would just be a square root that we add on top of the variance term. So there we have it. Out of the 4 principles, only the expected value principle does not satisfy consistency. For the next 2 requirements, see the next video. See ya!